Okay, this is a review of today's AQA GCSE Foundation Maths Paper 2, 2025, based on what students have reported. This is fair use for educational purposes. Okay, so first few starting off quite nice. I've got that something add on 8 is 19, so I think that something should be 11. 3 times something is 24, so 3 times 8 is 24. Of course, we maybe use our calculator for all of these just to make double sure on the actual exam, but we're just whipping through here and having a quick look at these. And 20 take away something is 7, so 20 take away 13 would be 7. Right. You've got sheep to cows in the ratio of 31 to 47. We're told that there were fewer than 100 animals in the field. So that means this is the ratio simplified. I can't double these up because then I've got more than 100 animals. So this is my amount of sheep and that is my amount of cows. How many cows are there? Well, there's 47 cows. How many animals are there altogether? Well, that's 31 plus 47. So that is 78 animals in total. 31 plus 47 is 78. Okay, so in this one, we were told that each square is worth 1 centimetre. Mine aren't a centimetre, but you'll have to bear with me on there. Each square is 1 centimetre, and each centimetre represents 10 metres. I've got a drawing of a path. So I've got A, B, and C. I'm told that this way is north. What is the direction of B from A? So I'm starting at A, I'm heading down to B. What direction am I heading? Well, never eat shredded wheat. I am heading east. What is the actual distance along the path from A to C? Well, that's 4 squares there, that's 3 squares there, so that's 7 squares in total. If each square is worth 10 metres, that must be 70 metres. Right, next few ones we had was simplified questions. So A times B, in algebra we'd call that AB, we just bang them next to each other if we're multiplying letters. C plus C plus C would be 3C. I've got 3 C's there, all added together. P times P times P is P to the power of 3, or P cubed. And D divided by D, well, anything divided by itself is 1. So D divided by D is 1. Right, in the next question, somebody walks 400 metres to the shop, 250 metres to a park, and then they walk 380 metres home. Show that they walk more than 1 kilometre. Well, I know that 1 kilometre is 1,000 metres. So let's just find out how far they walk. So I'm just going to add together the distances I've got here. So that's 400, add 250, add 380. I've not put that in right because it told me it's going to be more. 400 plus 250 plus 380. Checking on my answer line that I've put those numbers in correctly. So that is 1,030 metres, which is more than 1,000 metres. If you're not too sure on your more than and less than symbols, just write it out in words, and that way you can't make a silly mistake. Right, next question. I've not necessarily got them all here, guys. These are just the ones I have been told about. So, 80p is a fraction of a pound in its simplest form. Well, that's 80p out of a possible 100p, 100 pence in a pound. So I could simplify that using my brains, but since we're in the calculator paper, let's put that in my calculator. 80 over 100. If I press equals, my calculator is telling me that that is 4/5. What is 3.5 hours in minutes? Well, that is 3.5 times 60, because there's 60 minutes in an hour. So using my calculator again, might as well come in the calculator paper. 3.5 times 60 equals 210. So that'd be 210 minutes. What is 1,400 grams in kilograms? We know from a question before, but odd for it to come up twice, that there are 1,000 grams in a kilogram. No, that was kilometres, wasn't it? But that's still that K thing telling us K is 1,000. How many K do you earn? There's obviously how many thousand you earn. So I think that'd be 1.4 kilograms, because if I times that by 1,000, I'd get that. If I was in the exam, I'd check that on my calculator, but I'm quite happy to tell you guys that that is what we need to do. Right, next one. What is 32 kilometres in miles? Use that 8 kilometres is 5 miles. Well, I'd be tempted to put that 32 down there and ask myself, what do I times 8 by to get 32? Well, that's being times by 4. So if that's being times by 4, I'm going to times that by 4 as well. So that would be 20 miles. Right, the next question was about some people's working. So I've got a table showing me how many hours people work and how much of that time they spend online. So that's in hours, that's in minutes. It says that Nala starts work at 10:30. What time does she finish? Well, if she starts at 10:30 and she works for 4 hours, that should be 2:30 in the afternoon. The question asked in AM and PM, so I'm going to answer in AM and PM. I'm always just going to match the style of the question. Shay says he spent more than a quarter of his total working time online. Is he correct? Right, well, he spent 200 minutes online, so I'm going to say that's 200 minutes out of 8 hours. Well, 8 hours in minutes is going to be 8 times 60, which is 480 minutes. So then using my calculator, let's put that fraction in. So I've got 200 out of 480, which is 5/12. Not very useful to us in this situation, but actually as a decimal, that is 0.416 recurring. So that's as a decimal how much time he's spending online. We hopefully know, if we don't, again, we could use our calculator, that a quarter is 0.25. So that must be more than a quarter. Lots of other ways you could think about that, but that's the way I thought about that when I was asked about that one. Right, the next one was on similar shapes. So with similar shapes, the key thing is that one shape is an enlargement of the other shape, so I'm timesing that by something to get to there. In fact, I'm going to think about that now before I even read the rest of the question. So what do I times 6 by to get 15? I can find that out by going backwards. So 15 divided by 6. My calculator is telling me that's 2.5. So 6 times 2.5 is 15. So that's what I'm doing to my sides as I go that way. The question's asking me to find out y, which is that angle there. Well, the angles don't change when you enlarge a shape. It's still the same shape. If I draw a small square and then draw a large square, the angles haven't changed at all. So if that's 30, that's 30. So y is 30. Figure out x. Well, already thought about this, that from the small shape to the big shape, I times by 2.5. So that side to that side must be times by 2.5. So 3 times 2.5 equals, as a decimal, 7.5. So x equals 7.5. Alright, the next one we had some algebra. So I've got A and I've got B, and I'm being asked to show that A is equal to B. So I've got some brackets here. So if I see some brackets in the maths exam, I'm normally expanding them. So 7 lots of x is 7x. 7 lots of minus 2 is minus 14. Then I'm just going to copy the rest of those bits outside the bracket down. 7x add 4x would be 11x, and minus 14 add 6 would be minus 8. Again, I'm moving through quite quick here. In the exam, I'd obviously do that on my calculator so I don't make any silly mistakes. Let's hope that this comes out as the same thing, because I'm being asked to show that they are equal. So 5 lots of 3x is 15x. 5 lots of 2 would be 10. Again, just writing down the bits next to the brackets. 15x take away 4x is 11x. This is looking good already. Plus 10 there, take away 18 is minus 8. So I have proved that they are equal to each other. Next one, we had some stuff about some lovely apples. 4 lovely apples is £2.20. Find the cost of 7 of them. So I'd find the cost of 1 apple first. So to move from there to there, I'm dividing by 4. So I'd do the same thing there. So £2.20 divided by 4. Again, no need to do this in our heads because we are in the calculator paper. So £2.20 divided by 4 is 0.55. So they're 55p each. I'm going to keep that in pounds. if I want 7 of them to move from 1 apple to 7 apples, I'm just timesing by 7. So if I've times that side by 7, I'm going to times this side by 7. So my answer's still there from before. So let's just times that by 7. Fraction, so let's change that to a decimal. £3.85. Right, Aloy records the number of minutes she spends on a phone for 4 weeks. So I've got 140, 168, 205 and 192. What is the range? Well, the range is the biggest, take away the smallest. So the biggest is 205. The smallest is 140. So the range telling me that spread between the data. Again, reach for your calculator every single time. 205, take away 140 is 65. So the range is 65. Aloy records again for the 5th week. The mean is 178 minutes. How long was she on the phone for during the 5th week? Right, so a bit of deeper thinking here. Normally, if we're finding the mean in a normal way, we'd add up all the numbers, divide by how many we've got, and that'd give us our answer. So I add everything up, divide by how many, and that gets me my mean. So working backwards, instead of dividing by how many, I'm going to times by how many. So if my mean is 178 and it was 5 weeks, they must add up to 890. So it adds up to 890 all 5 weeks. So if I take away these 4 weeks, it should leave me with what it was for the 5th week. So let's take 140, take 168, take 205, take 192. So I think the total for that 5th week was 185 minutes. If I was in the exam, I'd check my work, I'd add all the 5 of those together, divide by 5, and I'd be looking for that mean to come out. Right, the next one apparently was a matching one, but I don't know what all the wrong answers were, so let's just have a look at what the questions were. N doubled, well, that's going to be 2n. N multiplied by itself, anything times by itself is squared. Half of n is n divided by 2, n over 2. 2 less than n, so I'm starting with n, I've got 2 less than that, so that is n minus 2. Right, on the next one, we were told that a rectangle has an area of 60 centimetres squared and a side length of 10. Pete says the perimeter is 32 centimetres because 60 divided by 10 is 6. Is he right? Right, little diagram, always nice to help us think about these. So if my area is 60 centimetres squared, I'm being told that my side length is 10. For a rectangle, base times height would get me my area. So something times 10 is 60, so that must be 6. This is looking very similar to what Pete's saying. Pete said 60 divided by 10 is 6. If I want the perimeter, that's all the way around the outside. So that's going to be 10 plus 10 for those two sides, plus 6 for those two sides. Which again, I do it on my calculator, but I'm quite happy to tell you that that is 32 centimetres, which is what Pete said. So yes, Pete is right. Well done, Pete. Right, the next one we had was a rearrange. So I've got that a plus 3 equals b, and I'm being asked to make a the subject. That just means I want a on its own. So if I want a on its own here, I need to get rid of that add 3. So I'm going to take that away from both sides. So a equals b minus 3. Next question was a Best Buy question. So you had these 2 bags of rice. One bag was 200 grams for £1.10. The other bag was 500 grams for £2.60. And we were being asked which is the better value. Now, a couple of different ways to do this, but I'd always go for how much it is for 1 gram. Now, I'm expecting this to be a small number. 1 gram of rice isn't going to cost me a lot. So from there to there would be dividing by 200. Anything divided by itself is 1. So to be fair, I'm going to do the same on that side and divide by 200. So £1.10 or 1.1, you could put the 0 on if you want, it doesn't make a difference, divided by 200 equals, that's a fraction I want, a decimal. So my calculator is telling me, can we see that? 0.0055. going to do the same thing over here, so I've got direct comparison. 500 grams to 1 gram is divided by 500. So I'm going to do the same on that side, divide by 500. So £2.60, again, put the 0 on if you want, don't if you don't want to. Divided by 500, 0.0052. So the best deal is going to be the cheaper one, the one that's the least amount of money. This one is the cheapest. So from there we had a question about getting the bus and getting the train to work. So Ben uses the bus or train to get to work. He gets the bus on 1 day, he gets the train on 8 days. Write the ratio of buses to trains. Well, that's just 1 to 8. Feels suspiciously easy. Starting to look a bit tricky here. I've got 6a to 5a and it wants it in the form of n to 1, so it's telling me to make that number 1. Now again, it's already come up a few times in this exam, but anything divided by itself is 1. So I'm going to divide this side by 5a. So I'm going to do the same to the other side, because everything in maths land is a fair thing. So a divided by a, again, would be 1. Anything divided by itself is 1. Which will just leave me with the 6 divided by 5, which it wants as a decimal, and my calculator is telling me that that is 1.2. So it is 1.221. Right, next question. Bit of an oddity that. We don't often see things like this. 1 to x is the same as x to 4. Find x. So there's a missing number here. It's the same number in both things, and I want both of these ratios to be equivalent to each other. So I think that x equals 2, and that's because if I've got a ratio of 1 to 2, this thing's twice as big as that, and if I put 2 in over here, this thing is now twice as big as that, so that's the same ratio. And in fact, it would simplify to the same thing, confirming that they are the same thing. Right, probability, spinners. Spinners are red and green only. Spinner 1, the probability of red is 3/8. Spinner 2, the probability of red is 1/5. So we're being asked to complete the tree diagram. Remember, probabilities on a tree diagram, as you go down sort of like each pair of branches, in this case they're pairs, it should add to 1. So if that's 3/8, that has got to be 5/8, because 5 plus 3 is 8. If that's 1/5, that's got to be 4/5, and it's the same thing, it's the same spinner here. We're just going down what happened on a different one on spinner 1. So that's got to be 4/5 as well. Question at the bottom, both spinners are spun. Work out the probability that both spinners land on red. So that would be going along this bit and then going along this bit. So I need to multiply along my tree diagram. So 3/8 times 1/5, again, do this on your calculator if you want, is 3/40. Alright, I've got red and blue discs. 70% of the discs are red, the rest are blue. So actually, as I'm going along, I'm just going to decide that that's 30% now as I go along, so I'm not going back to start thinking from the beginning. 40% of the reds are removed. 50% of the blues are removed. What percentage have been removed? So it can be kind of tricky sometimes to start a question like this. We don't know how many discs we've got. I am going to assume that there are 100 discs, just because that's a nice round number. There's 100% in a full amount of percentage as well, so that's going to lean into things being easy for me. So I'm just going to assume there are 100 discs. If 70% of them are red, well, out of 100, that's 70 that'd be red. The rest are blue, so that must be 30 that are blue. I'm told that 40% of the reds are moved. So again, I can do 40% on my calculator, or I could do that in my head. Again, we're in the calculator paper, so let's do it on the calculator. So 70 times 40% equals 28. So that's 28 reds taken out. 50% of the blues are removed, so that is 15 blues removed. 50% is just half of it, isn't it? So 15 is half of 30. What percentage are removed? Well, I've got 28 that are removed there for the reds. I've got 15 that are removed for the blues. So together that is 43 removed. Now you can see another reason why it was so nice that I chose 100. 43 out of 100 is obviously 43%. Right, after that we've got one about a theme park. So we're told that adult tickets are £2.50 each, student tickets are £16.25 each, and you get one free adult ticket for every 5 students. We get told there's 48 students. The total price, so for everybody who's going, that's 927 quid. How many adults went? Right, well, first off, I've got 48 students. So if I get a free adult ticket for every 5, I think that's 9 free adult tickets. Sorry, I'm coming up against my boundary there. 9 free adult ticks. So now I just need to find out if we've paid for any adult tickets along with this. So if 48 students each have to pay £16.25, we can find out how much that is. So 48 times £16, you can't see what I'm doing, 0.25. So that's £780 on student tickets. Take that away from my total amount, it should be just the adult money that's left. So 927 take away 780. 927 take away 780 equals £147 spent on adult tickets. We know that adult tickets are £24.50, so I want to know how many £24.50s fit into that. So 147 divided by £24.50 equals 147 divided by £24.50 equals 6. So we've got 9 free adult tickets, 6 adult tickets that we paid for, so that is 15 adults that went on the trip. Alright, the length of the fence panel is 160 centimetres to the nearest 10 centimetres, complete the error interval. So when I do these, I like to think about it like this. 160 centimetres is where I'm at. The next 10 up would be at 170, and the next 10 down would be at 150. Excuse us. So the place where I'd stop rounding to 150 and start rounding to 160 would be at 155. And if we think about that, 154, I would round to 150 to the nearest 10, whereas 155 I would round up to 160. Same thing for the upper bound, so that'd be 165. So the smallest it could be is 155. You can see on the answer line it's telling us that's included. The biggest it could be, technically, is just a tiny, tiny wafer under 165, which is why my sign's saying it's less than 165. Because technically that'd round up, but 164.9 recurring is essentially 165. That's quite a cool proof. We can look at that another time, perhaps. A different fence panel measures 2 metres to the nearest 10 centimetres. Show that 3 panels must be less than 6.2. So I'm going to set out it in very much the same way. If I've got 2 metres to the nearest 10 centimetres, the next 10 up would be 2.1 metres. The next 10 down would be 1.9 metres. So my lower bound would be 1.95 and my upper bound would be 2.05. Show that 3 fence panels must be less than 6.2. So I'm on about the biggest. So 2.05 times 3 of them. So 2.05 times 3 of them. Calculator's telling me the very, very maximum that could be is 6 metres, 15 centimetres. So 6.15 is less than 6.2. I've proved it. Circle the factor of 3x plus 15. So which of these things goes nicely into 3x plus 15? I think it's that one, and I can prove it. So if I was to put 3 as another factor, 3 times x is 3x, 3 times 5 is 15. So I've proved that x plus 5 is a factor of 3x plus 15. Right, getting into some of the meatier questions now. So, I've got this circle. I'm told that the circumference of the circle is 20 centimetres. I'm being told to assume that x, that degrees in there, is 90 degrees. Find the shaded area, so that's this bit here. Hopefully that's showing up all right. So, I think that normally to find circumference, that is pi times diameter. We could talk about why I say it like that another time. So if circumference is pi times diameter, and I know the circumference is 20, 20 is equal to pi times diameter. So if I want to undo that to find what the diameter is, I'm going to do 20 divided by pi, and that'll tell me what the diameter is. So bosh that into my calculator. 20 divided by pi is 6.3661977724. Now, I'm a bit funny when I do these. I tend to keep all the decimals all the way through and then round it right at the very end, just so that I don't get any little errors cropping up. That is my circumference. If I want to find the area of that bit, area is pi r squared, so I'm going to need the radius. A radius is half of a diameter. That's the way I remember it, because that sort of looks like a circle. So my radius must be half of this number I've got here. So if I half that, that is going to be my radius. So I'm just going to write that down so that the examiner can see that I know that. So the radius is 3.183098862. So I'm going to find the area of the whole circle by squaring my radius and timesing it by pi. So let's do squared times pi. So my whole circle is 31.83098862. I've not got a whole circle. I've got a quarter of a circle because that's 90 degrees, so I can make that a right angle actually. So I'm going to take my answer and divide it by 4 to give me the chunk that I am after. So that is 7.957747155, which is obviously more accuracy than anybody needs. But at the end, I'm just going to round that. So I'm going to call that 7.96. And I'm going to tell the examiner that I've rounded that to 2 decimal places. If they don't want it to 2 decimal places, they have got my full unabridged answer there. Right, if x is smaller, what does that mean for the area? Will it be smaller? Will it be the same? Will it be larger? Will it be any of the above? Well, you can think about this even without the answer. If that angle's smaller, I've got less shaded stuff, so it must be a smaller area if that angle is smaller. Final question, really trekking here. So, trigonometry question, it's asking me to find x, so I'm going to label up my triangle. That's the hypotenuse, because it's the longest side. That's the opposite, because it's opposite the angle. And that's the adjacent, because it's the one that's left over, or the one next to the angle, some people say, but it's always just the leftover one for me. I'm going to write out SOHCAHTOA. I write this higgledy-piggledy so that it's already in my triangles. Now, I know the adjacent, so I'm going to tick those. I want to know the opposite, so I'm going to tick those, which is showing me I'm going to be using my tan triangle. Because it's the opposite I want, I'm going to cover that with my thumb. These two things are next to each other, which is telling me to times them. So I am going to always do the side first, 4, which is my adjacent, times, I'm in the tan triangle, so tan of my angle. So 4 times tan 36 equals, again, I'm going to be over the top and write down the whole number just in case that's what the examiner wants to see. But then I'm going to tell him that that's 2.9 to 1 decimal place. Right, what do you think, guys? Was it a good paper? Was it a bad paper? How'd you get on with it? Did you like it? Any further questions? Let me know. I like reading the comments. I'm always quite happy to reply. Get in touch.